you know I like the function to be there, just in case. X, the square root of 6 minus x. I'm sneezing, sorry about that. 6 minus x. Yes, I know you don't need in most of the new calculators, you don't need parentheses. Good, so all I want is to plug in 4. Give me the number, 5.7. So 5.7. At this point, I need to make sure that these two rows are not in conflict. They cannot be in conflict. Then, if they are in conflict, then I know, oops, something is fishy. Okay, so let's check. From negative infinity to 0, what does the function do?
Increase.
Is that supported by the sign of the derivative? Yes. Awesome. From 0 to 5.7, what does the function do?
Increase.
Is that supported?
Yes.
From 5.7 to 0, what does the function do?
Decrease.
Good. Is that supported by the sign of the first derivative? Yes. What type of point is 4, 5.7?
IP.
We are not on the second derivative. We haven't reached the second derivative. The IP is given only by the second derivative. So look at the signs.
This is the local max.
The local max. It could be absolute, but for now it's local. Okay, it could be. So now finally we have to look at the second derivative. Find critical numbers for the second derivative, study the sign, and we're done. We're ready to graph. Okay, this is not a friendly function now. How come? Look what I have to differentiate. Awful. So I'm copying f prime here, negative 3x minus 12 over 2 the square root of 6 minus x. Okay, so this is not a friendly function now at all. When I square the denominator, I have 4 and 6 minus x. I have to differentiate the top, and I get 3 times the denominator. That part is easy. But now minus the top. I should have pulled out a 3 to make it even easier. Well, I didn't, so now it's too late. Times, I am going to do that because I also want to take the 2 out. So sorry about that. I need to make it as easy as possible. I should have done that from the beginning. So f prime of x has a negative 3 over 2 in front. And then I have x minus 4 over the square root of 6 minus x. So let me explain what I did. I don't want to have all these extra numbers in here if I don't need to. So I factor out a 3 here, and I got x minus 4. 3 times x and 3 times negative 4. And I pulled the 2 because it's a constant in front. It's a factor. I pulled it out. So I'm going to keep this constant outside. And now I'm going to differentiate this. You can say, just a poor 2 in there bothered you. Yes, it did. Okay, so the second derivative, negative 3/2. And this can wait. The top prime is 1 minus the top times the denominator prime, which we know is 1 over 2, the square root of 6 minus x times the inner function prime over the denominator squared. Okay, fine. Negative 3/2 in front. The least common denominator, I know you're going to say the same thing, but let me simplify it a little bit. Or not. Still the same thing is a 2 the square root of 6 minus x. still a 2, and then 6 minus x, and then minus. The denominator here is still 2, the square root of 6 minus x. This one is still 6 minus x. And now let's see what we have. Negative x times negative 1. So in other words, you can consider that these two cancel out, right? Negative times negative. So this is positive x minus 4. So let's review this because it's dense in here a little bit. So I pulled out the negative 3/2 because I really didn't want to worry about this number. Make it as simple as possible. So the top prime is 1 times the denominator minus the top times the denominator prime, which is 1 over 2, the square root of 6 minus x, times the inner function prime. I realized that in the numerator, there is only one denominator, which is 2 the square root of 6 minus x. I have, like before, I have to multiply 6 minus the square root by 2 the square root of 6 minus x. We get the same thing, 2 times in parentheses, this product, 6 minus x. And then minus 1 times negative 1 in front become positive. It's a product. I have to multiply. Just make sure this is a product. So then I have x minus 4. Now this is over 1, so I'm going to flip it. So negative 3/2 in front. And now I will expand the numerator. So 12 minus 2x plus x minus 4, everything to 6 minus x, the square root of 6 minus x. So it is very easy to forget. I wanted to say that a couple of students did that. A couple of you made that mistake. When you find the derivative of a quotient, please do not forget the denominator. It's very easy, very tempting to drop the denominator, but we can't. Okay, finally, I have negative 3/4. The denominator is 6 minus x, the square root of 6 minus x. And now what do we have here? We have negative x and 12 minus 4. It simplifies nicely, but the calculations are not friendly. So 3/4 x minus 8 over 6 minus x, the square root of 6 minus x. Okay. So two options. Well, this is undefined where the function is undefined, so nothing from the second derivative being undefined, nothing. No. But when is this 0? Can anyone tell us when is this the second derivative 0?
Is it when x equals 8?
Yes, indeed. X equals 8. Go back to my table. So it doesn't fit in the table. I still have to study the sign. So I have no choice but study the sign. So see what it is. Which portion of this you will not study the sign for? Because it will be a waste of time. So there is no inflection point because 8 is not in the domain. I cannot determine the function value. It doesn't exist. It's up here. So no inflection point, but I still have to determine the sign so I know if it's like this or it's like this. So which of this expression, which piece or pieces of this expression you will completely ignore when studying the sign? Just for studying the sign.
Denominator?
Excellent. That changes the sign. This is always positive. We established that from the very beginning. Excellent. Well done. Don't waste your time. So tell me the sign for any value less than 8. Plug in any value less than 8 and give me the sign of the second derivative. can plug in 0.
Won't it be negative?
Absolutely, thank you so much. I established the symbol. I know exactly how it looks like. I don't need any of this. Now all this information is gibberish. Nobody cares about it. Nobody cares about any of this but the table. See, I could have not done this with a whiteboard in front of you in the classroom. But look what I can do now. That's it. Nothing else matters. I write in class. I write on same, and everything is the same. So I haven't written it on the whiteboard or chalkboard in 15 years or more. Okay, so I have to plot 0, 0, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 up here somewhere, and 6, 0, 5, 6, 0. I'm sorry, this was 4, 5, 6, 6, 0. That was 5. That's 4 and that's 5. I don't want to confuse anyone with this point here. So eventually it will dry out. Good. Perfect. So then it's coming from negative infinity, opening down, increasing through the origin. Okay. I can do this, but I cannot use this for a while. I guess I need, okay, perfect. So then it continues to increase to the local max, which now I know it's an absolute max. And then it still continues to open down, but now it's decreasing to the x-intercept 6, 0. That's the graph of f of x, x the square root of 6 minus x, and this is now I can write local and absolute max. After I established all the signs and everything, it's very clear why this is an absolute max. That's also the second derivative test if you want, or just a test for us. So if the function opens this way, of course that when the first derivative is 0, this point must be a max, because the function opens like this on this territory between negative infinity and 6. The function opens downward. If there is a critical number somewhere here, it must be a max because the function opens this way. Good. I need these to scan. So one more time, look at all this work. If I don't summarize the information in a table, I will not know what to do with this information. It will not tell me anything. But what's all this? These are all calculations. They mean nothing. But once I have summarized the information, I know when it's increasing, the function is increasing, function is decreasing, and function is always opening downward. Now I know how to graph it. Going from left to right, step by step, plotting the points I have first, and then analyzing increasing, opening downward, decreasing, opening downward, local, in this case, absolute max. Once you understand the table, you will be pros in graphing. Any questions on this? Any question? Yes, please. Gabby?
In WebAssign, we were supposed to refer to like the maximum and minimums as x values.
Yes.
Would we,
no. So when they ask about the maximum, they're asking you about this. When they're asking you where the maximum is, you're going to say x equals 4. How much is the maximum? 5.7. They may ask you for the ordered pair. Then you will put 4, 5.7. But if they ask you where is the maximum, you have to say at x equals 4. If they ask you what is the maximum, then you have to say 5.7.
Okay.
Is
Thank you.
that better?
Yeah.
Perfect. If they ask you for the ordered pair, you will say 4, 5.7. 4, 5.7. Good. Other questions from WebAssign or anything else? Let me know if we want to choose another problem, or we will look at rational functions now. We have not graphed any rational function yet. If you don't say anything, then I panic. I'm not sure whether my students are following me or have a question or.
Can we do one more of those type of equations?
Yes, of course. Looking at rational functions, everything will be the same. We're adding a little bit more because rational functions are a little bit different. But the concept will be exactly the same. But of course, please choose anything. Or
Can we look at
yes,
56?
56, this one. Very good. Awesome. Perfect. Let's take a look at 56. Good point. I'm on page 5. And let's look at 56. 56. F of x equals natural log of x squared plus 9. And this is 56. Good pick. Yep. We want to see all types. We've seen one of this. We've seen one of this. We've definitely seen polynomial. We want to look at exponentials. We want to look at log. We've seen trig function. Awesome. Perfect. Good. So I get my table going right away where I put in everything. This will help me graph the function, nothing else. But of course, it requires a lot of work. Perfect. So what is the first step? We're asked to graph this function, and the first step would be always
determine the domain.
excellent. So what do I have to write in order to find the domain of a log function?
Is it all numbers are positive number for that?
This has to be a positive number. Natural log is applied to this. But x squared plus 9, do I have to write that this has to be positive? Do I have to write this?
I thought it was just that ln, like the graph of ln, had to be greater than 0.
No. So let's talk about that. So this is the graph of pure natural log x. This exists only when x is strictly greater than 0. There is nothing else. X equals 0 is a vertical asymptote. So this quantity has to be positive. Whatever this is has to be positive, not 0, just positive. But the answer, this, can be anything. The range of this function is from negative infinity to infinity. We're not asked about the range. We're asked about the domain. So the domain of this function is 0 to infinity. Now, natural log of anything, this quantity has to be greater than 0 unless it is already greater than 0. It's very similar to the square root. If I have the square root of whatever, this whatever has to be greater than or equal to 0. But here I cannot have 0. So these two are kind of similar in domain, but not 0 here, but 0 here. So coming back to our function, this expression has to be greater than 0. But do I have to write that x squared plus 9 has to be greater than 0? Anyone?
It will automatically be
Absolutely.